Alright guys, this is 3-1 in advanced geometry. Today we're finding some slope. It's all review, so determine the slope that contains the given points. And remember the slope formula. M stands for slope. Slope is going to be y2 minus y1 over x2 minus x1. And just to refresh, remember this is x1, y1. This is x2, y2. So what I need you to do is give me a little m equals right here to say the slope, and let's do y2 minus y1 over x2 minus x1. So we got minus a minus there, which becomes a plus, and then we'll do a little 2 over 1, which is just plain old 2. And then we like to tell if that line is horizontal, vertical, or oblique. Well, every horizontal line will have a slope of 0. So since this guy's slope is 2, he's not horizontal. Every vertical line slope is undefined, so that's not undefined either. So this is an oblique line in that situation. It's oblique. Let's find the slope of the next dude. So we'll do a little m equals negative 7 minus 5 over 1 minus a minus 2, which that's negative 12 over 3, which that totally reduces to negative 4. And since we didn't get 0 or undefined, that's an oblique line. So that guy is oblique. Finding the slope on the next guy, we do a little m equals 3 minus 1, y2 minus y1 over 3 minus 0. And we get ourselves 2/3. And since that's not undefined or 0, that's going to be an oblique line that goes up from left to right since that's a positive slope. And we'll do that on 4 here. The slope, negative 4 minus a minus 2, so it turns into a plus, or 5 minus a minus 5, so that's going to be negative 2/10, which that can totally reduce to be negative 1/5, and that is an oblique line. And just keep it on, keep it on. The slope on the next one, 9 plus 1 over 3 minus 3, which is going to be 10 over 0, and uh-oh, that's where we run into problems. The first commandment of mathematics is thou shalt not divide by 0, so this needs to simplify. It simplifies to be undefined. But that means that since that's an undefined slope, that's a vertical line in that situation. Vertical line. You're going to have to memorize that all vertical lines have an undefined slope. And on the last one here, the slope will equal 6 minus 6 over negative 1 minus 4. We get 0 over negative 5, which that can happen. You can take 0 and divide it by negative 5. You'll get 0. You can't divide by 0. Like you can't have 0 downstairs, but you can have him upstairs. So all horizontal lines have a slope of 0 in that situation. So that's old school finding the slope. Y's are on top. Next guy, we can find the slope of a line that's given to us. We just count. You know, that's going to be a rise over run situation. So we count from one point to the next. Here's the point N. Here's the point P. We can count rise. 1, 2, 3, 4, 5, 6. Over run. 1, 2, 3, 4, 5, 6, 7, 8. 6 over 8, which can reduce to be 3/4, and that is totally a positive slope because of the lines going up from left to right. So m equals 3/4. And this guy, he's going to be a negative slope. You see how that guy's going down from left to right. So find you 2 points and just go down 2. So down 2 means that's negative to the right one. So the slope is negative 2. And this guy, he's a vertical line. His slope is undefined. And the reason why is because there's totally no run. If you pick any 2 points on there, like if you call this point A and you call this point B, you could rise 1, 2, 3, 4, but run nowhere. There is no run. So that is not cool. That is an undefined slope. So the slope is undefined. Doing a little counting, rise over run. Now some story problems. Finding the rate of change. One thing that always boggles students' mind is if I ask you to find the slope, they can do it, but if I say find the rate of change, they don't know what to do. Rate of change and slope are the same thing. So here's a little story problem. In January 2015, Dwayne "The Rock" Johnson had 38.38 million Instagram followers. Then in January of 2018, he had have 98.16 million Instagram followers. Find the rate of change. So what we're going to do is we're going to write two ordered pairs. So let's use the first bit of information that I give us here. Ooh, look at that beautiful color of a highlighter. Let's change it to orange. In this first bit of information right here, I need a time first. Time is usually your X value. So in 2015, and we were in January of 2015, and so was the other information. So we can just straight up use the year 2015. He had 38.38 million Instagram followers, so I can just use that decimal. And then the other ordered pair would be 2018. He had 98.16 million Instagram followers. And to find the rate of change of that, we totally find the slope. So the slope will be y2, 98.16 minus 38.38 over 2018 minus 2015. And we do a little punching in, 98.16 minus 38.38, and that's 59.78, and that's over a 3-year period. So let's think about what this is saying here before we finish this out. This is 59.78 million Instagram followers over a 3-year period. Well, when we do a rate, we always want it to be over 1, so we're going to totally just divide this out and just get ourselves a decimal, and I guess that's approximate, so we'll need to say approximately 19.93, since they were using 2 decimal places, we'll do that, million what? The question is, who was upstairs and who was downstairs when it comes to labels? So upstairs, wasn't that our followers, right? How many followers they had on Instagram, and downstairs was years. So 19.93 followers per year is what that's all about. That's what happened. There was an increase because the slope is positive. The rock had an increase in that 3-year period of about 19.93 million followers per year. So there's a story problem. Let's do another story problem. Before it was demolished, the RCA Dome was the home to the Indianapolis Colts. For those who don't know, that's a professional football team. The attendance in 2001 was this much, and the attendance in 2005 was this much. What is the approximate rate of change in the attendance from 2001 to 2005? So let's write two ordered pairs. 2001 is a year, and here's the big old honker attendance, 746. And the other ordered pair was 2005, 457, 373. And let's find the slope. The slope will be big old boy, 47. Write down a little bit too, so I'm out of this. Let's just erase that. Let's do that. Let's just erase that. Meow. 4, 5, 7, 3, 7, 3 minus 4, 5, 0, 7, 4, 6 over 2005 minus 2001. So we go to the calculator, 4, 5, 7, 3, 7, 3 minus 4, 5, 0, 7, 4, 6, Boutros, 6,627 over 4. So since they want a rate of change, we'll divide it by the actual 4 and kind of see what's going on. So that is 1656.75. Then we need to throw the label in there. What was upstairs? It was the attendance, and usually that's people. So people per year was the attendance in that situation, and the attendance went up. Right, the attendance totally went up. If this rate of change continues, predict the attendance for 2012. So that's a good question right there. What you have to do is you have to pick one of these ordered pairs. Doesn't matter which one. I'm going to pick this guy. I'm going to use 2005, 457, 373. And then you write yourself another ordered pair. You know 2012 is a year, so that's going in here, but you don't know the attendance, so you're going to call him X. And I'm going to use this space provided that I have right here to do this work. But what we do is we use the slope formula. Now you don't have to write this down, but isn't this the slope formula? M equals y2 minus y1, over x2 minus x1. And we actually know, like, all of these except for one. We know we don't know y2 because that's this guy, but we know y1, we know x2, we know x1, and we actually do know the slope. The slope was this, right? So we can substitute the slope in for m, which is 1656.75. That's going in for m. And I don't know y2. I should have probably called that y. Let's not have him be a y. Let's not have him be an x. Let's have him be a y, because that'd be stupid to kind of make a y value variable x. So we're going to call him y instead. We're going to have y minus y1, which is 457,373, over 2012 minus 2005. So what we'll do next, all I did was substitute that in. I knew the slope. Here's y2, which we just called y. Here's y1, x2, x1. I'm going to clean this guy up right here. I'm going to scratch out 2012 minus 2005 and just call him a 7, right? Because that's what that turns out to be. So we do a little cleanup right there. And now we're trying to solve for y. Well, we got this nasty old fraction. What we need to do is just get rid of this, divide by 7 by multiplying by 7. So we'll take that 1656.75 and take him times 7. And I get 11,000 with a comma, 597.25 equals y minus big ol' honker number. And to solve for y, all we have to do is add it to this number in our calculator. So plus 457,373, baby. And that attendance should be, we're going to round this now because we don't really have 0.25 people, but 468,970. And I'm just going to round that down. So about that many people. We need a label in that one. So if the attendance kept going up by 1656.75 per year in the year 2012, based on those predictions, this is how many people there should be. So I use the slope formula to figure that out. Yeah, I know there's other ways that some of you would have figured it out. It's like, can't you just figure out that that's 7 years later? Yeah, we did that right here. And take that times your slope. Yeah, we did that here. And add it to what it was in 2005. Yeah, we did it right there. That's exactly what we did. A lot of the things that people would think mentally, I just did algebraically. And then they ask, will this attendance continue to increase indefinitely? Explain. Like, can the attendance keep going up and up and up and up and up at a dome that for the Indianapolis Colts? Well, that's a no. I mean, there's no way, because there's a maximum number of people that can fit into the dome. So it's like eventually there's like a breaking point in that situation. So they can't, even if they sold out every single year, it's like the slope's not going to keep going up. So not always going to keep going up. In 2000, Jefferson High School has this many students. By '06, the student body has increased, meow, to this many students. So that slope went up. When Fairview High School, a totally different high school, so we got Fairview and we got Jefferson High School, two different high schools. When Fairview was built in '01, it had 1275. How many students did Fairview High School have in 2006 if the student body grew at the same rate as Jefferson High School? So we got Jefferson and we got Fairview. Since we got two different high schools, let's do some labeling. Let's call this Jefferson over here, and let's do Fairview right here. And what they're asking is, like, if they grow at the same rate. So what I need to know is the rate of change for one of these high schools. Jefferson, I have some info. In the year 2000, the attendance was 1125. Sweet. There's an ordered pair. And in 2006, that thing was 1425. So I have that. What I know for Fairview is that in 2001, there was 1275. And they're asking me how many students did Fairview have in 2006. So in 2006, how many students? Well, I don't know that, so we're going to call him Y, but they're supposed to have the same rate of change. Well, what that means is I should probably find the rate of change for Jefferson since I have two ordered pairs. So let's do that. 1425 take away 1125 over 2006 minus 2000. 1425 minus 1125 is 300, and 2006 minus 2000 is 6, and 300 divided by 6 is going to give us 50, right? So the rate of change from Jefferson High School was they increased meow, meow, by 50 students per year. So 50 students per year. Well, Fairview is supposed to do the same thing. Since we know the slope and we're missing one of the ingredients, we're going to substitute into the slope formula. I'm going to start with the slope, which they're supposed to be 50 because they had the same rate, and that should equal y2, bing, minus y1 over x2 minus x1, 2001. So then do a little bit of cleanup. Clean this up to be 5, and let's multiply. 5 times 50, 150, or sorry, 250. My bad. 250 equals y minus 1275, and then just totally add 250 plus 1275 gives us a grand total of 1525 students. That says students. So if Fairview grew by the same rate. So again, you could figure that out kind of different ways. It's like, well, if it's going up by 50 students a year and it's 5 years, that means it goes up by 250 students, and then you just add that to the previous total. That's exactly what we did, you know? We just did it with algebra. All right, and then determine whether line AB and line MN are either parallel, perpendicular, neither. Justify your answer. So they give me all these ordered pairs. Here, they want to know about line AB and line MN. First, let's talk about what parallel lines are. You should remember that parallel lines have the same slopes. Parallel lines have the same slope, and perpendicular lines have opposite reciprocal slopes. Please spell reciprocal right. If you need to pause the video to write that down, you can. But opposite reciprocal, remember what that means. Like opposite means change the sign, and reciprocal means flip me over. So the opposite reciprocal of 2/3 is negative 3/2. This guy's positive, that dude's negative. If I give you like negative 4/5, the opposite reciprocal of that is a positive 5/4. You have to flip him over and change the sign to do the opposite reciprocal. So these problems are all about work shown and organization. We want to find the slope of line AB, whammy, and the slope of line MN. If they are parallel, they will be the same slope. If they are perpendicular, they will be opposite reciprocals. If they are neither, they will not be the same nor be opposite reciprocals. So let's try it. Here's how we show our work. We're going to find the slope of two different lines. So first we'll start with an M for slope, but since we want to find the slope of line AB, we're going to make a little subscript of line AB. That literally says the slope of line AB. That will equal, let's do us a little y2 minus y1 over x2 minus x1. And I haven't said it yet in this video, but you got to show all this work. We're not doing this in a calculator. You must write it down. If I write it down, you write it down. So I think you know that by now. Negative 10 over 5. The slope of line AB is totally negative 2 in that situation. Now, what we need to do is find the slope of line MN. So that's how we write that. And if the slope of line MN is negative 2, they're going to be parallel. If the slope is positive 1/2, they're going to be perpendicular. And if it's none of those, then they're neither parallel or perpendicular. So let's see what happens. Line MN's using these 2 points, M and N, and that would be a negative 1 minus 7 over negative 2 minus a minus 6, which is a plus. Negative 8 over 4, which needs to simplify to be negative 2. So are these lines parallel, perpendicular, or neither? Being as how those are the same, bro, they're parallel. Justify your answer. 2 words. same slope. That's all you got to do. You got to tell me that they're the same slope. That's how you know they're parallel. The work is our justification, and here is basically like how we knew that. Those lines are parallel because they have the same slope. So let's do that on 14. Squiggle! Find the slope of line AB. Bum, bum, bum. And that would be negative 5 minus 4 over 2 minus a minus 1. Negative 9 over a shui, which is a negative shui. Let's find the slope of line MN. I didn't switch colors. I would like to. So the slope of line MN is a 0 minus a 2 over a 3 plus a 3 in that situation, which is a negative 2, 6, which we usually call that negative 1/3. So let's talk. Are these guys the same slope? Absolutely not. They cannot be parallel. Are these opposite reciprocal slopes? No, they are not. This dude's negative, this dude's negative. They're both negative, so they're not opposite. Even though 3 and 1/3 are reciprocals, you have to be opposite reciprocals to be perpendicular. So this is a neither. And a lot of people struggle with the reason of why they're neither. It's actually the easiest. I'd ask you, how did you know it was a neither? And you'd say, well, they're not the same slope and they're not opposite reciprocal slopes. That's exactly what we write down. We write not the same slope and then use the word nor, opposite reciprocal, which needs to be spelled right, reciprocal slopes. The magic word is slope. It's got to be in there twice. Those were neither parallel nor perpendicular because you didn't have the same slope or you didn't have opposite reciprocal slopes. There is an E in slope. Check this word out. That's slop. We're not talking about slop. We're talking about slopes. So let's try 15 right here. Let's find the slope of line AB. That's going to be 2 plus 7 over 4 plus 2, and 9 over 6, which needs to reduce to be a shui halves. Find the slope of line MN. That would be 6 minus 0 over 2 plus 2, which is 6/4, which is a 3/2. Bing! Same slope, parallel. Double the L, parallel. Reason, same slopes. So homies, only one more problem left. Why don't you pause the video and give this guy a try.